All right, I wanted to do a video showing the proof for using the triple scalar product to find the volume of the parallelepiped. Um, just because I thought it was cool, and also just for practice for myself. But I thought maybe someone else would find it cool too, so I figured I would just put it here. So uh, what I oh yeah, sorry. Okay, so what I did is I took the sides of the parallelepiped and you make them equal to vectors. So like this is vector w, this is u, this is v, this is u, um, and like also like so like this right here is also w, and like this is w, and this is w, and like this is u, or this is v, and this is v, and this is v, and then this is like these are all the same sides, or in that like there's four of each of these lines in the parallelepiped. And so to find the volume of a parallelepiped, or any just like a rectangular prism, for example, you want to get the area and you want to multiply it by the height. So I have a shaded region here, and this is the area. So the area would just be like the base times uh, the height of the rectangular prism, because each face of a parallelepiped is a rectangular prism. So go over here. I drew one of the faces, and this is a rectangular prism with sides W, or not rectangular, sorry, this is a parallelogram, uh, and each with sides W and V. Um, and so the way that you would get the area of a parallelogram is you want to multiply the length and the width, which is represented by W. Anyway, but you want to get the length and the width. And so how I'm going to use W as the width, and I just need, so with W as the width, to get the length, I need a line that's perpendicular to W. So what I do is you would just do this. And this forms a right angle here because it's perpendicular. So as you can see, this is a right triangle. So you just get theta. Theta is the angle between vectors v and w, right? Because it's right here where they connect. And so now I want to solve for L, which is the length. And so L equals, using this, we have opposite over hypotenuse, which is, so it's going to be sine. So I'm going to do this actually. Sine theta is going to be equal to the opposite over the hypotenuse, which is just going to be the length or the magnitude of vector v. And now to solve for L, we would just do L equals this magnitude of vector v times sine of theta. And so this is the how you get the length. To get the area, you just multiply it by w. W being vector w, because or the width being vector w. Unrelated symbols. That's just bad framing on my part, I guess. Because L is perpendicular to vector w, it would just be represented by the magnitude of vector w. So to get the area is equal to L, which is the magnitude of, it's equal to the width, which is the magnitude of vector w, multiplied by the length, which is the magnitude of vector v, times sine of theta. Now, if you remember, this is actually the same thing as the cross product between W and V. And because this is supposed to be an area, it's actually going to be an absolute value. So this also, because of the fact that the cross product between V and W and V are, and well, the whole thing is, it's a magnitude. It's not okay. It's equal to the magnitude of the cross product. It's not equal to the cross product. The cross product is a vector, so we can't say it's equal to the cross product. But since it's an absolute value, and because the cross product of v and w is just going to be like the negative or the opposite of the cross product of w and v, we can use either of these because either way they're going to be an absolute value. So with that in mind, I'm not going to write the absolute value symbols anymore, just because with using the magnitude symbols with the cross product symbols, it's kind of confusing to read, I feel like. But this is what it is. It's the absolute value of v cross w. So come over here. So now we have the area, and to get the volume, we just need to multiply the area by the height. So how do we get the height? Well, it's very similar to over here. We need a line that's perpendicular to this this base here, this area. So we need a line that's perpendicular to the area. So there are two ways to do this, really. I'm going to show you my favorite way first, just because I think it's interesting. And then I'm going to show you a different way that it might be more easy. It might be more easy. And I'll probably split the video into like the two into sections so that you can choose which method you prefer. So first I'm gonna do this way. So basically, if you remember, a way to get a vector that is perpendicular to both vector v and vector w, you just get the cross product of them. So this vector right here, perpendicular to vector v and w, can be represented by the cross product of v and w. Okay, so that means that the vector the vector that is the cross product of v and w is in the direction that we want the height to be in. Of course, it's not going to be the magnitude we want the height to be in. So how do we get the magnitude? Well, the magnitude is going to be based on the magnitude of the height is going to be based on u. And so basically what we want to know the amount of u that is in the direction that's perpendicular to this area. So in other words, we need the amount of u that's in the same direction as v cross w. And so let me do this real quick. Right here is where the height is. I might get rid of that for now though, but this area here is where the height is. So how do we do that? Well, if you remember, we can do a scalar projection. We can project u, and let me write this h, this is the height, equals, we can project u onto the cross product of v and w. Okay, so now we have the volume is equal to the area, which if you remember is the magnitude of v and w, of the cross product of v and w, multiplied by the scalar projection of u onto the cross product of v and w. And so, if we simplify this further, and I'm going to pause this real quick just to write it out because it'll take a minute doing it with a mouse. Okay, if we write this out completely, we have this part right here, still the magnitude of the cross product of v and w, multiplied by u, the dot product of u, and the cross product of v and w. So u dot v cross w, all over the magnitude of the cross product for v and w. So now these two cancel out, and what we're left with is the volume is going to be equal to the dot product of u and the cross product of v and w, which is the triple scalar sum. So the volume of a parallel pipette is equal to this. Now, the easier way to do this, probably, I don't know if it's easy, it really depends. But another way to do this is right here, we know that this is the height, right? So we know we want to solve for this, and this is going to form a perpendicular line. This invisible line I drew right here is going to form a perpendicular line, but Um, and then this angle right here is going to be the angle between you and this area here, this base. So with that in mind, we can essentially figure out, or we essentially can, if we're trying to get this height, we can figure out what the height is by using a cosine. So cosine of theta, which is by the way going to be different from this theta, completely unrelated. Cosine of theta, which is just the angle between you and this area, is equal to the height adjacent over the hypotenuse of the triangle, which is the magnitude of vector u. And so now we know that the height, and here let me separate these. Let me write method 2. So I'm drawing with a mouse, it looks really bad. So cosine theta is equal to the height over the magnitude of vector u, and so now we know that the height is equal to the magnitude of vector u times cosine theta. So now we have the height. And so remember, to get the volume, we just have to multiply the height by the area. So we already have the area. It's just going to be the magnitude of v times, or the cross product of v and w. So v equals area times height. And that means that v is going to equal area, so magnitude of v cross w, and u, or in the magnitude of u, which are multiplied by the height, which is the magnitude of u. Let me do that. Times cosine theta. And now, if you remember, this is the same thing as for the definition of a dot product, as saying u dot v cross w. And so we have that the volume is again equal to u dot v cross w. And so that's another way to prove how to find the volume of a parallelepiped using using the triple scalar product. But yeah, I thought this was really fun and interesting, so I figured I would share it with people. Let me know what you think.